Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. This is our third and last class in section 3.6. Today we will solve the recitation exercises and some old exam questions. As you know that this section is about rational functions, mainly about the asymptotes of these kind of functions. The first rational function that you should think about is 1 over x, the reciprocal function. Why? Because it is the mother of all the linear functions, linear over linear. They are obtained from 1 over x by some transformations. The vertical asymptote is a vertical line. When we approach it, this line, the function goes to infinity or negative infinity. The horizontal line, the horizontal asymptote, is a horizontal line. The function approaches this line when x goes to negative or positive infinity, simply like that. The graph never ever intersects its vertical asymptote, but it may cross its horizontal and its slant. It may, if it has. These are some examples that we had in the previous classes. You have several methods to sketch, for example, the graph of this function. You can do it by long division and then look at it as transformations of 1 over x. Or you can just find the vertical asymptote, horizontal asymptote, x-intercept and y-intercept, and you will be able to sketch the graph. How to find the asymptotes if you have a rational function? If you have a rational function, the vertical asymptotes will be the zeros of the denominator after canceling the common factors between them, between the numerator and the denominator. For the horizontal, it depends on the degrees. So if the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. If the degrees are the same, then the horizontal asymptote, it is the leading coefficient over the leading coefficient. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote in this case. And we had several examples about that. Some of them, they cross the horizontal asymptote, some of them they don't. Also, we have considered the case when you have a common factor between the numerator and the denominator. Like this, for example. In this case, you will cancel, but you should consider where you can cancel, where the factor is not 0. The original function that you have, its graph will be the same as the resulting function, but of course, except at the point that you exclude, except at 2. And in this case, you have what is called a hole or a point of discontinuity. More 2 examples about this we had in the previous class. So here, after the cancellation, we still have a horizontal asymptote at 0, but at 3, we have a hole. The last part, it was about the slant asymptotes. What is the slant asymptote? The slant asymptote is a line that is not horizontal, not vertical. It is a line with positive or negative slope. How to obtain it, and is any real function has a slope, a slant asymptote? It is not. Only rational functions with this specific property. The degree of the numerator is one more than the degree of the denominator. So this is the case that you have slant in that case. What is it? If we have, so you will know that if there is a slant or not. The question is how to obtain the equation of the slant asymptote. The idea is to do just the long division. Just use the division algorithm to obtain. For example, here we have a polynomial here of degree 2 divided by a polynomial of degree 1. So in this case, the degree of the numerator is 1 more than the degree of the denominator. So we have slant asymptote. How to find it? Apply the long division. You can now divide by x minus 3 and continue the division until the end, until you have a degree less than the degree of the divisor. Now the quotient of the division here, the quotient, the result, is the line that you are looking for. Y equals to x minus 1 is the slant asymptote. Yes.
So whenever we have slant asymptote, we don't have a horizontal, right?
When you have,
Slant asymptote, we don't have.
of course, why? Because the degree will be greater than, when the degree, not necessarily the difference should be 1. Whatever the difference, if they are not the same, we don't have. Good. So we solved also this one in the previous class. Let's solve this one. Please try to solve this recitation exercise. We did this, by the way, almost in every example in the previous class. So please try to find an answer for this question. Write your solution in your notebook. Of course, horizontal asymptote, it is horizontal line. Any horizontal line, its equation will be y equals something. So here he told you that the graph intersect its horizontal asymptote. The question is where or when it will intersect it. At which value, x value, it will intersect. They will be intersect each other. The concept, what is the concept behind this? What you need to do first? What is the first thing you need to do? Find the horizontal asymptote. What is the horizontal asymptote? Y equals a half is the horizontal asymptote. For those who didn't find the horizontal asymptote, what you will do? This is the concept that we are talking about, Shabab. So first of all, find the horizontal asymptote. Then, let me see, Shabab, please continue. For those who they didn't finish, please continue solving.
I didn't just find my answer.
Yes, it's so clear. But I just would like to make sure that the concept is there, how to solve such problems. So easy. We solved, I think, 2 or 3 problems similar to this in the previous class. For those who solve, you can check your answer now. This is the right answer. What you need to do, guys, first of all, find the horizontal asymptote. What is it? Y equals, we have the degrees are the same. The degrees of the numerator and the denominator are the same. So it will be the leading coefficient over the leading coefficient. So it will be 1 over 2. This is the horizontal asymptote. Now he asks about the graph of this function intersects its horizontal asymptote. In general, when you have two graphs, when they will intersect each other, maybe point, maybe more than 1 point. Let me, for example, give you another one like this. So now this is y equals g of x. And the original one is, let's say, y equals f of x. You have two graphs for two functions. By the way, not necessarily functions, any two graphs for any two equations. Let's say here two functions. Now look here, they are different. But what is going on when we are at the intersection point? They are the same. Here the y and the x values are different, but at the end, at the intersection point, they are the same. So here at this point, x and y, the function f of x, it is the same as the function g of x. They are equal to each other. If you want to find the x-intercepts, the intersection points between two graphs, equate their equations. So here you need to equate just y here and with y here. So what you will do to solve such problem, you will just write the equation here, the y that you have there, over 2x squared plus x plus 10, you will put it equals to a half. Now, this is an equation, you need to solve it. Just solve this equation. The x that you will obtain, it will be lying on both graphs at the same time. As y here is a half, y here is a half. X you will obtain from here, it will be the same as you will have in that graph. Now, it is an equation, rational equation. To solve it, you need to do cross multiply. 2x squared plus x plus 10. Now cancel. You will have 6x plus equals to x, so it will be 5x equals to 15, 14. Just you will bring this here and bring that one there. X equals to 14 over 5. Now, what is the intersection point? The intersection point, it is 14 over 5 and what? And a half. If he asked about the intersection point, he just here asked about what is x equals what. But this is the intersection point. Why we didn't need to go and substitute back by x? By the way, if you put here x equals to 14 over 5, you will get a half at the end. Just after a long time, you will do that. No need, because it will be the same y as here, the same y. This is the intersection point. Any question, Shabab? Yes. How to, this is about the concept, Muhammad. How to find the horizontal asymptote in general. You need to go back to this slide. How to find the horizontal asymptote if the degrees are the same. From here, the leading coefficient over the leading coefficient here. The degrees here are the same. The degrees here are the same. So it will be the leading coefficient here, which is 1, over the leading coefficient here, which is 2. So it will be 1 over 2. Now solve this one, Shabab, and I'll take the attendance during that. So let's pause the recording. Okay, now the answer is B. But why? Why it is not A, for example? How to solve such questions? Let's consider this question, because you have here 5 options. So you will play the game of elimination. You will exclude the answers that they are not applicable. But I want you also to think about how to solve this one without choices, without options. How can you do that? Okay, let's start now with what? In such kind of questions, Shabab, you need to do what? You need to get your information from the graph. So let's start from here. Let's say what? From the graph, what we have? From the graph, what is the vertical asymptote? X equals 1. So this now will help me to exclude the choices that they are not possible. Okay. So what we will do, we will exclude now what? Which answer will be excluded? C. So C is not included. So this will exclude C. Because the vertical asymptote here is -1, x equal -1, not 1. For the others, they're still, of course, in the game. Let's now go to what? To the horizontal. Now, what we will do, we will find the horizontal asymptote. The horizontal asymptote is y equals to 1. Now, this will exclude what? This should exclude D. So D now will be out. Because the horizontal asymptote here is what? Y equals 2, not y equals 1. Okay, now the semifinal now, it is between the semifinal between A, B, and what? And E. Now what we can do more? The x-intercept and the y. What do you think? Which one we will start with? Let's start with the easier, the y-intercept. What is the y-intercept? The y-intercept, of course, it is about what? 0 and -1. So when x is 0, y is -1. Let's go to A and check. What will happen in A? We will get what? If x is 0, we will get 0. So this is excluded. It is not an option. So this will exclude A. Now what about B? When x is 0, what you will get? -1. It is N. Now let's go to what? E. What is left? E. When x is 0, 0 and -2, it is not. It is out. So now we are sure that our Answer is B. You can also use the x-intercept as a checkpoint, just to make sure that it is really B. Okay, why you didn't think about it like transformations? Why you didn't say this? I saw Mansour, he's raising his hand. Why you didn't say this? It is the same as the graph of 1 over x, shifted 1 unit to the right, then shifted up 1. Why it is not like that?
Yes, but there's
Look, if we say that, what we will get? We will get 1 over x minus 1 plus x minus 1, right?
Yes.
Which will be what? X over x minus 1, which is A. Why it is not A?
Didn't satisfy the graph.
What we are missing here, there is something missing here with that. We did a mistake here. We consider 2 transformations, but maybe there is a 3rd transformation that we didn't consider. What is it? The vertical stretching or shrinking. So who said that it is not vertically stretched? So in fact, it is 2 over x minus 2. Look, now the 2 options are the same. Now this is B. How to know that? If you divide this by this, if you did the long division here, x plus 1 over x minus 1, you will get this. You will get this one. Okay. Now, how to solve this without choices, Shabab? You will do what I did here, but you will say what? The graph here will be the same as the graph of 1 over x, but vertically stretched by A. I don't know what is it, but I know that A is what? A is positive. Why A is positive? There is no reflection. Then what? Then shifted 1 unit to the right. Then shifted up 1 unit. Now, how to find A? Use 0 and -1, or use -1 and 0. You have 2 points here. One of them will give you, of course, the value of what? Of A, and you will know what is A that you are looking for, and you will know what is the vertical stretching that you have. Clear? Okay, go to this question now and solve it, please. Khalid, are you Khalid Hazimi? Where is Khalid? This is your last quiz. Okay. For those who want to check their answers, the answer is y equals to 3. The idea, the concept, how to solve such questions. So easy. Now, some of you may say, he wants what? The horizontal asymptote. The horizontal asymptote will be y equals to what? The degree here, it is of this is of degree 1, this is of degree 1, the same degrees. So it will be the leading coefficient over the leading coefficient. Here it is, which is, by the way, A over A minus 2. But it is not in the choices. So this means that you need to find what? To find out what is A. So in fact, the main task is to find A. So how to find A? For sure, he will not give you this one for fun. He gave you this this details for a purpose, for a reason. So here you will use this one to find A. So let's go back and start over again. So what we will do, we will use what we have to find what we want. So we have vertical asymptote, x equals what? 5. This means what? If we bought the denominator equals to 0, x will be what? What we will get if we solve this one? If we know A, assume that we know A, what is it? If we solve this one, what will be x at the end? Now, if I bought x equals to 5, I should always get 0. So here what you need to do, just bought x equals to what? To 5. This what will give you 0. Now you have an equation with one variable. It will be 5 equals to what? A minus 2 times 5. Divide both sides by 5. A equals to what? 2, 3. This is A. Now update your function. your function will be what? Your y will be 6 minus 3x over 5 minus a minus 2, 3 minus 2, it is 1x. Now, what is the horizontal asymptote? Will be y equals to negative 3 over negative 1, which is what? Which is 2. Now, consider this concept, and many questions will be like this question in all the exams, as you will see. Now, please solve this one, and I think that this one will summarize the section. It is the best end for this section. This is the last recitation exercise. Find all the asymptotes and holes, if any, for the graph of this rational function. Okay. How to start solving this question or any kind of questions like this?
Completely.
But I think there is something that you can conclude without factoring. So we can say that there is no horizontal asymptote. Why there is no horizontal asymptote? The degree of the denominator is greater than. Okay. Now, then we will try to find what? The vertical asymptote, right? So to find the vertical asymptote, you need to factor first. So what we will do, let me say here no horizontal asymptote here, and then we will start factoring. I will factor here. So it will be x squared, and here you will have x squared minus 4. Okay. Minus 4, and you can factor this more, by the way. And now in the denominator, you need to use grouping. The first two terms, x squared as a common factor, you will have x minus 2. We need to have this in the second group. So we will take negative 4 as a common factor. Now this is the new common factor. Factor it out. What you will have here? You will have x minus 2 multiplied by x squared minus 4. By the way, x squared minus 4 can be written as x minus 2 times x plus 2. Now we factor this completely, and here x squared, it is also x minus 2 times x plus 2. Now, this is your favorite part, the cancellation. You can cancel this, and you can cancel this. Then we obtain x squared, this is what is remaining, x squared over x minus 2, provided what? Provided that x is not positive or negative 2. Okay. Now, what we can conclude now? We still have, of course, our conclusion will not be changed, by the way. No horizontal asymptote. So, in fact, we can conclude that from the beginning. No need to repeat. So now let's talk about the vertical asymptote. What are the vertical asymptotes? The zeros of the denominator. So x equals what? 2. Now, what about holes? Do we have holes here? Do we have how many?
2.
What they are? Are you sure? So what do we have at 2? At 2, is it a hole or a vertical asymptote? How to know that? How to know? Is it a hole or a vertical asymptote? No, don't. Sketching the graph is not practical. How to sketch the graph? Yeah, Shabab, what is going on when x approach A? When x goes to A from the left or the right? Look here, what will happen? It will go to what? So this is the x-axis. This is the y-axis. So this is the point or the line x equals 2. This is x equals 2. What will happen here? Is it going to be a hole like this, or it will be a vertical asymptote like this? How to know what is going on when x approach 2 from the left or from the right? What will happen to the function? It will go to infinity or negative. When it is from the right, it will go to infinity. If it is from the left, it will go to infinity. So do you need a hole here to say that it is undefined? You have, in fact, a black hole here, the vertical asymptote. That, of course, when the graph approach A, it will goes infinity or negative infinity. So in fact, we have a hole just at what? at -2. At x equals 2, we have what? We have a vertical asymptote. Now, if it happens that we cancel no more denominator, then we can say that there is no positive or -2. If we don't have a vertical asymptote at 2, we will have a hole for sure, right? What else?
There's a slant.
Good. And this is, by the way, was missing in the old slides. So this is why I upload the slides today again and update that there is also slant asymptote for this one. Why? The degree of the numerator is 1, exactly 1 more than the degree of the denominator. So we have slant asymptote. How to find the slant asymptote? The slant asymptote will be y equals what? You will do the long division. So it will be what? X squared divided by x minus 2. It will be x squared minus 2x, subtract. You will get 2x. Now you can keep dividing. Don't stop here. The degrees are still the same. So you stop when the degree is less than. So you will divide, you need to multiply by 2 to have the same as this. 2x minus 4. Now subtract, you will get 4. Now focus just on what? On the quotient. What is the quotient of the division? So now the slant is what? Y equals x plus 2. This is the slant asymptote. And the answer is here. No horizontal asymptote, vertical asymptote x equals 2, a hole at x equal -2, and slant asymptote at y equals x plus 2, the line y equals x plus 2. Look at the old exam questions. If you don't have question about this, yes.
How we can sketch the graph if there is x squared?
You are not supposed to do. I told you we will just ask you about linear over linear. If you are interested, it is in your book how to sketch the graphs. You will study more about it in Math 101. But for now, in this course, if they will ask you about the graph, they will ask you just about linear over linear. And this includes, of course, constant over linear. But it is not difficult. You need just to find the vertical asymptote, the horizontal asymptote, the slant if there is slant, and of course the x-intercept, the y-intercept. You can of course sketch the graph. Look at the old exam and you can see, Shabab, that most of the ideas are coming from where? From the recitation exercises. If x equal 2 is the vertical asymptote, then what is the horizontal? He can give you the horizontal and ask you for the vertical the same way. Here he gives you the vertical and ask about the horizontal. What about this one?
We just solved the recitation.
So we have time. Let's solve this, please. Solve this one. Good to check your now. Imagine that you are in the final exam. This is a final exam question. And it is really, it is final exam question. You should be able to solve it within 5 minutes. Indeed, you can solve it in 1 minute, let's say 2 minutes at most. Are you done, Abdul Aziz? What is the answer that you have? What is it? -1. We will see. 5, -1. We will see. Continue solving. Umar, you said 5. Abdulaziz, you are saying -1. One of you, he's not right. Please check. One of you had a mistake. You still have time to change your mind. Who support Umar or Abdulaziz? Muhammad? 5? 5? Also you? 5. Okay. The answer is 5. Why? And you need to find what is U, what is V, what is omega. Okay. What is the easier one to start with? Indeed, all of them are easy. U or V or omega, or call it V and W, it's okay. It is indeed nu and omega. So what we will do, we will go to the graph and get the information from the graph. So from the graph, what is the vertical asymptote? From the graph. So let's write them here. Vertical asymptote from the graph is x equals 1, right? Now the horizontal asymptote from the graph, y equals negative 1. If we need anything from the graph, we will go back and get it from here, okay? Here we are. Now, from the function, what is the vertical asymptote? 1 minus omega x equals to what? To 0. To find the vertical asymptote, you will do this. But you know that now that x is what? Is 1. So this means that 1 minus omega equals to what? 0. So the omega is what? Is 1. So we obtain omega. Now from the horizontal asymptote, from the function, what is the horizontal asymptote? It is y equals to u over negative omega, right? So we don't have u, but we have omega. So it will be u over negative 1. And it should equals to what? To negative 1. This one. So this means that u is what? 1. What is remaining? V or nu. How to obtain this? So we need to go back to the graph and get what is the y-intercept or the x-intercept. Let's take the y-intercept. What is the y-intercept? 0 and 3. When x is 0, y is what? Y is 3. So from here, what is the y-intercept from the function? It will be what? 0 plus v over 1 minus 0. By the way, it was the first one. We were able to find this from the beginning, even without knowing what is u, and we don't need u and w here. So it will be just what equals to what? To 3. This implies that v over 1, which is v, equals to 3. Now the sum of these three numbers is 5. Yes.
How did you obtain that x equals 1 in the first
From the graph. Here we have it from the graph, from here. This is the horizontal,
Yeah, but
and this is the vertical. Now, if we put this equals to 0, we are assumed to obtain 1. So it will be at, this will be to be more accurate, this will be at x equals 1. Okay. Excellent. Any more questions, Shabab? So I think we will stop here. Most of all the exams are with the same ideas. Of course, you should focus on the concept. The conceptual understanding will help you to solve any question, even if it is new for you. Let me stop the recording here.